Bismillahirrahmanirrahim. Assalamualaikum and a very good day to everybody. So for today's lecture, we will begin the first topics for the design for manufacturing assembly courses, which is the introduction to what we call as the DFMA. So my name is Muhammad Zairi bin Baharum from Faculty of Mechanical and Automotive Engineering Technology, University Malaysia Pahang. Yeah. For today's in this video lecture, I will briefly introduce to you uh, about the design for manufacturing and assembly, which is the DFMA. First, we will look under the brief introduction to DFM, what we call as a design for manufacturing, and then what is the concepts of DFMA, which is a design for manufacturing and assembly, and then we will continue on the classification and differences of DFM and DFA. DFM stands for Design for Manufacturing, and DFA stands for Design for Assembly. So basically, DFMA is a combination of DFM and also DFA. So there are seven main principles of design for manufacturing and assembly. There are seven main principles. The first one is to minimize the number of components, meminimumkan bilangan component. So thereby reducing the assembly, we can achieve the principles of minimizing the number of components by reducing assembly and ordering costs, reducing the work in process, which is the WIP, and also simplifying the automation. The second principle is design for ease of part for fabrication. So the geometry of parts that has been designed is simplified and unnecessary features are avoided. Yeah? The third principle is the tolerances of the part. So the part should be designed to be within the process capability. So when we design the part, we should be able to define the process capability and match it with the tolerances of the part that we design. And then the following principles, the fourth principle is clarity. Clarity means that the components should be designed so they can only be assembled one way, which is by using this principle, it will ease the assembly process. The fifth principle, to minimize the use of flexible components. So parts made of rubber, gasket, cables should be limited as handling and assembly is generally more difficult. So it's pretty difficult to proceed with the assembly process if you design a part which is made of rubber, gasket, cables, and so on. Yeah, and a few other examples of this. Yeah, and then the sixth principles is to design for ease of assembly. For instance, to design a part or a product that could ease the assembly process, the use of snap fits and adhesive bonding rather than threaded fasteners such as nuts and bolts. So it's better to use a snap fits or adhesive bonding, and if possible, a product should be designed with a base component for locating the other components quickly and accurately. And the last principle, the seventh principle, is to eliminate or reduce the required adjustments of the parts. So designing adjustments into a product means there are more opportunities for out of adjustments conditions to arise. So we do not want the conditions of out of adjustments to arise in our product during the assembly, because it will bring a problem to the assembly. Yeah? And then DFMA involves two methodologies, which as I mentioned before, DFA and also DFM. So what is DFA? DFA involves design for a product's ease of assembly. Yeah, E stands for assembly. Yeah, so it is concerned with reducing the product assembly costs and minimizing the number of assembly operations. And while DFM, M stands for the manufacturing. DFM is a process of designing parts, components or products for ease of manufacturing with an end goal of making a better product at a lower cost. So the combination of DFA and DFM is DFMA. So DFMA is a design approach that focuses on ease of manufacture and assembly and efficiency of the assembly. So both of these two methodologies, which are DFM and also DFA, seek to reduce the material, the overhead, and also the labor costs of developing a product. So these are the two combination of two different methodologies which form the DFMA. So what are the objectives of DFMA? So there are 6 objectives of DFMA. The first one is to differences and similarities between DFM and also DFA, since these both two methodologies form the DFMA method. Second one is to describe how product design has a primary influence. Yeah, to describe how a product design has a primary influence. Yeah? And then the third one is a basic criteria for part minimization. So the FMA is a basic criteria to minimize the number of parts in a product. The fourth one is to quantitative analysis of a design's efficiency. So by using the FMA, it is a method that we can use as a quantitative analysis method to evaluate our design's efficiency and also to critique a product design for ease of assembly. So when we develop a product, we can do a critique session using the DFMA just to focus on the ease of assembly of the products that we are currently designing. Yeah? And then the importance of involving production engineers in DFMA analysis. So before we hand out, we deliver the product to the production line, we do the DFMA to the whole design process of our product, and we should also involve the production engineers. How important to involve this group of production engineers in the DFMA analysis. Yeah. So these are 6 objectives of the DFMA. So showing in this figure is a few examples of design features that affecting the assembly process. As I mentioned before, the use of snap fit. You can see in the first figure on the left is the snap fit. The second one is the press fit, and then the integral rivet, the separate rivet, and the last one is screw. These 5 are the examples of design features that will affecting the assembly process of a product. Yeah. Okay. What is the use? What is the use of DFMA? So DFMA is used as the basis for concurrent engineering studies to provide guidance to the design team in simplifying the product structure to reduce the manufacturing and assembly costs, and also to quantify for improvements. Yeah, you can see that when you are designing a product, you will have a design team. Yeah, a design team to simplify the product structure, and at the same time you have to think on how to reduce the manufacturing and assembly costs, and also to quantify any improvements that you suggest or want to implement in the product's design itself. The second usage of the DFMA is as a benchmarking tool, yeah, to study the competitors of the competitors' products, and also to quantify the manufacturing and assembly difficulties. So there must be a benchmarking sessions or study that you did before you produce a new product. So you will use this method also to benchmark with the other competitors who also produce the same products, yeah, or quite a similar product to the product that you want to design or develop. And the third one as a should cost tool, yeah, to help to control the overall cost and to help negotiate a supplier's contract. So DFMA is a very comprehensive method that will help you to control and manage all the costs related to the development of the product, and at the same time it will help you to negotiate while develop a contract with your particular suppliers who involved in the development process of the parts of the products, yeah. So we go first to the DFA, which stands for Design for Assembly. Yeah, Design for Assembly. DFA is focusing on the optimization of the part or system assembly. So the definition of DFA is a method of design of the product for ease of assembly. So again, the focus is for ease of the assembly process. So DFA is a tool used to assist the design teams in the design of the products that will transition to production at a minimum cost, focusing on the number of parts, handling, and ease of the assembly. So you can see that these are a few important factors which DFA is beneficial, which are again to reduce the cost or to minimize the cost, to focus on the number of parts, minimizing the number of parts, and handling and ease of assembly. So what is DFM? DFM, yeah, Design for Manufacturing, which focus on the optimizations of the manufacturing process, yeah, to optimize the manufacturing process. So the definition of DFM is a method of design for ease of manufacturing of the collection parts that will form the product after assembly. So you will have a huge, maybe hundreds or 200 numbers of parts that will form to a single product that you develop. So you will use DFM as a method to design for ease of manufacturing to handle all those parts that will form to a product, to a final product, yeah. And then DFM is a tool used to select the most cost effective material, yeah, and process to be used in the production in the early stage of the product design. So it is crucial for you as the product designers or the design team members to select the most cost effective material and processes that you will use in the production to produce the product, yeah. So we talk a lot about DFA and also DFM. So again, DFA concerns only to reduce the product assembly cost by doing a few actions like minimizing the number of assembly operations, and individual parts tend to be more complex in design. And DFM again concerned to reduce the overall part production cost by minimizing complexity of the manufacturing operations and use a common datum features and primary access. So these are the differences between DFA and DFM, which I think you can clearly see that one is deal with the assembly and another one is deal with the manufacturing process. Yeah. Okay. So what are the similarities of DFM and DFA? There are several similarities of DFM and DFA itself. So both of these two methodologies are seek to reduce material overhead and also the labor cost. And then both of these two methodologies also targeted to shorten the product development cycle time. So each product that has been developed have its own development cycle time. For example, if you are developing a new model of a car, it might need 1.5 or 2 or more than 2 years, yeah, as the new product development cycle time. While if you are developing a mobile phone for now, so you can see the race, the competitions of introducing the new model of the mobile phone. So you can see how short is the product development cycle time for the new model. Yeah, sometimes the new model that has been introduced in the market is not a totally new, so we call that as an extension model. For example, if Apple is introducing the iPhone 10, yeah, and then suddenly after a year or maybe 10 to 11 months they come out with the iPhone 10 XS or XR, so we call that as not a totally new product development, but that is a kind of an extension model to the current model. Yeah, for the car model, you can also see that the car manufacturers, when they are introducing the facelift or a special edition for a car, so that is also called as an extension model. Yeah, so both methodologies of the DFM and DFA also seek, yeah, to utilize the standards. Yeah, so DFM and DFA have its own standards to reduce the cost. Yeah, again, to reduce the cost of the total manufacturing cost of the product. Yeah. Okay. Uh, Over the wall design. Over the wall design, if you can see, is the figure. Yeah, in the figure is the historically the way of doing business. Yeah, I also have an experience when I work with Panasonic as the mechanical design engineer. So what we did is we received a design from the industrial designer in Japan, and then we have to develop the 3D model, we have to build the prototype and then plan for the tooling design and then do the injection molding. So what we did is the other side of the wall. So industrial designers is at the other side, which is at the area of the design in this house, and next to the wall is me, who is sitting as the mechanical design engineer and also the manufacturing team. So traditionally, yeah, the attitude of designers, yeah, has been like this: we design it, and then you build it. We might be the designers, might be the industrial designers or the design team who sketch and also come out with the concept design of a product, and you who built it is the manufacturing and also the engineering team, yeah, who build the product. Yeah, okay, so this has now been termed the over the wall approach. Yeah, so this is the design team could consist also as the industrial design together with the mechanical design, and the other side of the wall is the manufacturing team who are going to produce the product. So sometimes there are also conflicts between the mechanical designers and also the industrial designers. Yeah, industrial designers, they want the shape of the product as what they imagine, as what the initial idea that they have. But when it comes to the mechanical designers, you have to try to materialize the design from the industrial designers to be looked as close as possible to the design proposed by the industrial designers, and also think of the capability to produce the parts. So in my opinion, the mechanical designer sits in between the industrial designers and also the manufacturing people. Yeah, so again, this over-the-wall approach where the designer sits on one side of the wall and throws the designs over the wall to the manufacturing engineers, yeah, who then have to deal with the various manufacturing problems arising because they were not involved in the design effort. So in the DFMA, it is also important, yeah, for you to involve the production engineers and all the manufacturing people in the early stage and also in the development process of the product, so that this kind of expert people from the manufacturing world, from the manufacturing team, they can share their opinions on what on how the capability of the process that they have, or based on their knowledge, to produce the design that you imagine. Yeah. Then in this figure, you can see who casts the biggest shadow. So we can see the involvement, yeah, the involvements of different factors, yeah, in developing a product. Like only 5% involved with the product design, 50% is focusing on the material, 15% on the labor, and also the remaining is on the overhead. Yeah. This is the flow of doing the DFMA study steps. So you will have a design concept in the beginning of the design process, and then you go for the design for assembly, which is DFA. And then during the process of doing the DFA, you will have suggestions for simplifications of the product structure. Yeah, this can be done by discussions among the design team itself. And then after you finish the DFA, you will do the selection of materials and processes, and also early of the DFM, or the design of for manufacturing cost estimations. And then during this stage, you can do a suggestions for more economic materials and processes that can be used, yeah, to minimize the total cost of the developing the product. And then you will proceed with the best design concept based on the several design concepts that you generated. And then we go to the design for manufacture, yeah, DFM. And then we do the detailed design for minimum manufacturing cost. Yeah, again, in the industry, they will target for the minimum manufacturing cost. And then I think this is the stage that you can have a critic sessions and also a very detailed discussions to improve the product itself, on targeting the most minimum cost for it. And then you can also, after that, you will continue on developing the prototype of it. Yeah. Now there are several rapid process that you can use on developing the prototype. Yeah, you can also use like the 3D printing, yeah, to develop the prototype of the product. And then the last one will goes to the production. Okay, so these are the steps of doing the DFMA study. So short short keywords, yeah, for the DFA principles, the design for assembly principles. I list out here 10 principles. First, you minimize the part count, meaning that you try to minimize the number of parts. Yeah. Then second, design parts with self-locating features. The third one is design parts with self-fastening features. 4, you minimize the reorientations. Yeah, minimize the reorientations of the parts during the assembly. Yeah, again, the target is to ease the assembly process of it. And then the fifth one is design parts for retrieval, handling, and insertion. Yeah, this is really important for the assembly process. The sixth principles is emphasize the top-down assemblies. Yeah, so the movement of the from top to down. Yeah, assemblies process. And then the use of the standardized parts, or yeah, standardize the parts. The following principles is encourage a modular design, and then design for a base part to locate the other components. Yeah, you have a base, yeah, or the main part to locate the other components, and also design for component with a symmetry insertion. So these are 10 principles of the DFA. Yeah, before we end this lecture, yeah, I would like to show an example of the motor drive assembly. Yeah, you can see that this is the example of the original design of the motor drive assembly. You can see there are many parts. You have the cover, a set of screws. Yeah, you have the base of the motor drive, which is made of aluminium, all the sensors, and then there is also the end plate screw. You have the motor, the bush, the plastic bush. Yeah, there are so many parts in this original design. So when the design team perform the DFMA analysis and they do the improvement of the designs, so they can redesign the motor drive assembly and minimizing the total number of parts. Yeah, so you can see now the differences, yeah, between the previous design of this. You can see that the cover plate, the cover, and also the end plate screw, so it has been improved of the design. Yeah, and also a major reduction, yeah, a major reduction of the number of screws used, yeah, in this assembly, and also the bush and the other fasteners. Yeah, so this is how the DFMA methods and all helps the designers, yeah, to redesign the motor of the drive assembly. So by implementing the methodologies of the DFA, it can help you as a designers to improve the design of your product. Yeah. Okay, I think that's all for this lecture. I hope you enjoyed and also get benefits on the introduction to DFMA. So thank you and see you again.